Hello everyone, thanks again for tuning in to my high-tech video series using some advanced paper, pencil, and an iPhone to record all this stuff. So this is a more abstract version of the last video where we're talking about a repeated prisoner's dilemma. This is prisoner's dilemma game. So imagine W, X, and Y are defined to make this a prisoner's dilemma game. That, of course, would have to mean that W is lower than 10 because everyone getting mean is worse than everyone getting nice. And Y has to be greater than X. And in fact, Y has to be the biggest of all, and X has to be the smallest of all. And in this repeated prisoner's dilemma game, let's say the discount rate is 0.9. And, sorry for a sec, got a pencil to point at this stuff. All right, so this is a prisoner's dilemma game. The discount rate is 0.9. And just to review what that means each period you value stuff, you value stuff getting next period at 0.9 less, times 0.9, we get this period. So getting $1 next period is just as good as getting 90 cents this period. And if it's 2 periods from now, getting $1 2 periods from now, that is worth, delta 0.9 squared today. So getting $1 2 periods from now, that's as good as getting 81 cents today. Now we're going to try to find when there is a Grimm equilibrium if you play this game forever. So imagine two people are playing this prisoner's dilemma game forever, and they know what W, X, and Y are. And I'm trying to ask, when is it that there exists a Grimm equilibrium? So when does a Grimm equilibrium exist in this game? And we're always going to be looking at the no regret outcome. So in a no regret outcome, you're going to say, given that the other person's playing Grimm, I don't regret playing Grimm. Okay, because remember, that's what no regret means. No regret, like, two people can choose A or B. And I say, when is all A? Everyone playing A, no regret. Well, it's no regret if I'm willing to play A, if you're playing A, and you're willing to play A if I'm playing A, and that has to mean if we can only do A or B, if you're playing A, I'm better off playing A than B, and if I'm playing A, you're better off playing A than B. Now, if we made the game symmetric, and we have here, it doesn't matter for player 1 or player 2, then we only have to check it one way. If I'm better off doing Grimm if you're playing Grimm, it has to be that you're better off playing Grimm if I'm playing Grimm because the whole thing is symmetric. So, to see if there's a Grimm equilibrium, and remember, again, Grimm is the strategy of, I'm going to start playing nice, and I'll keep playing nice as long as you're playing nice. But if you once deviate to mean, I will play mean forever after. I can't play mean the round in which you play mean because this is a simultaneous move game. So if you're mean to me in round 8, I don't have a chance to change my behavior until round 9. So with Grimm, the round after you're mean to me, I start being mean to you and I'm mean to you forever. But also with Grimm, I'm always starting out being nice. So to see when there's a Grimm equilibrium, we have to say, hey, what do I get if I play Grimm given that you're playing Grimm? Now, if we both stick with Grimm, we're both nice forever. And in this game, if you're nice forever, you get 10 every period. And remember we did, if you play the game forever, you basically multiply what you get each round times 1 over 1 minus delta. So if I am Grimm and you're Grimm, we do this forever. The payoff is going to be 1 over 1 minus delta. I know what delta is, but I'll put that in later. Now, what if you're playing Grimm and I deviate? So I'm like, I'm going to take advantage of you. Well, what do I get? Well, we will end up with mean forever except for the initial round. And the initial round, instead of getting W, because I've taken advantage of you, I get Y. So a quick way of writing that is, if we're mean forever, I'm getting the mean forever payoff. I'm getting W forever except in the initial round. Well, in the initial round, that's right now. There's no discounting. So I'm going to get W forever, except in the initial round, I'm going to get Y and not W. And that means the extra amount I get is Y minus W, right? And you can see this easily. What if for some reason this wasn't a prisoner's dilemma game and Y was equal to W? Then this term should be 0 because I'm getting W forever. I'm not getting a bonus. If Y is 1 more than W, right, and I take advantage of U, so I get the take advantage of outcome of Y, well, then I would get an extra 1 this round, So for every dollar amount that Y is above W, that's the extra amount I get. So this has to be my payoff if I am mean forever where you're playing Grim, and that's because this Y minus W is how much extra I get in the initial round, and then I'm getting the W forever. So then we just use some algebra, we work this out. I know what delta is, and then 1 over 1 minus 0.9, that just means multiplying things by 10. So, 10 times 10 is 100, and then it's 10W, and then W minus Y. Simple rearranging, and I get 100 is greater than or equal to 9W plus Y. So in this game, I haven't told you what W, X, and Y are, but if we knew what W, X, and Y were, then there would exist a Grimm equilibrium if 100 is greater than 9W plus Y. All right. The big question. This will test if you understand this or not. And if you don't, it's okay. You can look at the other series of videos, do homework. But here's W, here's Y. Where's the X? There was an X here and an X here, but there is no X. The X doesn't seem to be relevant for determining if a Grimm equilibrium exists. Why would that be? In fact, I never wrote X. It wasn't like X got canceled out somewhere. It never, ever appeared. Did I make a mistake? I don't think I did. I did make a mistake, and then I threw it out, and I started again. So I made a mistake, but I don't think this is an error. Why is there no X? It's here. It's in the prisoner's dilemma game, but there's no X anywhere in whether a Grimm equilibrium exists. Try to figure this one out. What's going on? Why no X? Pause the video. Okay. Hopefully you've paused the video and thought about it, or you're texting your friend and this is just going by and you'll give it some thoughts later. What is X? X is what you get if the other person takes advantage of you. X is what you get if you're nice and the other person is mean. So X is not relevant if you're both sticking with Grimm, right? You're in equilibrium. X is completely irrelevant to you because I'm Grimm, you're Grimm, you never get taken advantage of. Now we're asking in a no regret equilibrium if you should stick with Grimm if the other person's sticking with Grimm. That means what's relevant is Y. Y is that what you get if you take advantage of the other person, but it's never relevant what happens to you if that other person takes advantage of you. Just because what we're asking for, is there an equilibrium where both people play Grimm? We're saying, are both people better off if they're certain the other person's playing Grimm than they themselves play Grimm? And in that calculation, you're never considering the fact that you might get taken advantage of. So that's why X doesn't come into play. All right. Now you'll see W and Y are here, but the W has a 9 before it and the Y does not. Why is the W 9 times as important compared to Y? What's going on to make W so much more important than Y for determining if a Grimm equilibrium exists? Please think about it. Well, Y, this is in W and Y determine what happens if you don't go along with the Grimm equilibrium, right? If you do go along, you get 10 forever, and discount rate of 0.9, that turns into 100. So going along with the Grimm equilibrium, if you know the other person does, that gives you 100. That's what this 100 is. And, it was saying, well, can you do better by taking advantage of the other person? Well, if you take advantage of the other person, you're going to get y once. Well, you're going to get w an infinite number of times. That's why w has 9 from it's bigger. Now, it's not infinitely bigger because they're discounting, so even though you get it an infinite number of times, you get it into the far future and it's not as important. But still, with a delta of 0.9, it's still, the w that you're going to get forever starting next period is more important than the y that you'll just get initially. So that's what's going on in this game. This, by the way, relates to the in the other video series, Repeated Prisoner's Dilemma. So I'd like you to watch the other series. I imagine at some point there'll be a Zoom lecture related to this. Haven't done it yet, but maybe I have by the time you're watching this video. And after this video, if you get this, you can do homework 9. So please, if you understand this, look at the other videos. Now is the time to do homework 9. Thanks for listening. Stay safe, wash your hands a lot, and maintain physical distancing for people not in your household. The stakes are shockingly high.